Here's an example of retrosynthetic analysis and forward synthesis of a ketone. Let's go ahead and label this ketone as A. And I will number carbon atoms starting with the end closest to the functional group. I just want to keep track of all of the carbon atoms. So my carbonyl oxygen is at carbon number 2. So when I'm thinking about the immediate precursor to a ketone, which is an enol, I immediately imagine that the O of the enol, the alcohol, will be at carbon number 2. And the double bond of the enol, the ene part, will be between carbons 1 and 2. So let's go ahead and draw the precursor. So here's cyclopentyl, carbon number 4, 3, 2, and 1 with the double bond between 1 and 2. And with the alcohol at carbon number 2. So enol is the tautomer of ketone, an intermediate. And the immediate precursor to an enol is an alkyne with a triple bond between carbons 1 and 2. So precursor to my enol B will be terminal alkyne 4, 3, 2, and 1. Don't forget to extend the triple bond in a linear fashion. And I will call it precursor C. 1, 2, 3, and 4. Precursor to a terminal alkyne is acetylene. So retrosynthetic arrow. Acetylene, which will give us carbons 1 and 2, plus the alkyl halide portion, cyclopentyl, carbons 4 and 3, with the leaving group, iodide or bromide, attached to the carbon that will be bonded with carbon number 2 in a chain extension reaction. So I will go ahead and label this alkyl halide as my Rx, and now I can show the forward synthesis. We always begin with acetylene. Those are carbons 1 and 2. And carbon-carbon bond forming reaction or a chain extension reaction involves 2 steps. First, we'll deprotonate one of the terminals, one of the hydrogens of acetylene using sodium amide in liquid ammonia, followed by addition of the alkyl halide Rx. That will give us extended alkyne C. Going forward then from C to B, we're adding water. That's a hydration of the triple bond. Notice that the hydration is proceeding in the Markovnikov orientation, with the OH adding to the more highly substituted secondary carbon, and hydrogen adding to the primary carbon. So for Markovnikov type of hydration of an alkyne, we need sulfuric acid with mercuric sulfate catalyst in aqueous solvent. So THF with addition of water. That will give us tautomer intermediate B, which will then spontaneously tautomerize without adding any reagents to our desired ketone product.